good to go. I'll say 5 and then I'll shut up. Welcome everyone to the Radix Dev Swarm event. My name is Adam Simmons. I'm the Chief Strategy Officer here at RDX Works, the main development company behind the Radix Public Network. First and foremost, can I give a huge welcome to everyone joining us today. I know we've got locations in Portugal, Germany, Hungary, Austria, as well as many more people joining us from all over the world. It's honestly so humbling to have so many people excited, like us, about the future of DeFi and Web3. And we hope that what you see today with Scrypto and Radix is going to help you start your journey into that future world. Now, we've got a lot planned today for the Scrypto event. And if you haven't already done so and you're planning to code along, please make sure that you've got your machine set up with all the software that you're going to need. The details for that are on the event page. They're also on the YouTube description. So go and do that while I do the little introduction bit if you haven't already done so. And if you're one of our live venues, you can always flag down one of the team to give you a hand if there's any problems. Now, let's start the show. So I'm going to be kicking off today with a quick background on Radix and why we're here today with you and what we believe about the future. So one of the biggest obvious questions is, why is it that Radix build what we build? And it comes down to one simple thing. We believe that finance today is failing users in over 1,000 different ways. And generally, these are small ways. So things like transferring your pension can take months and a mountain of paperwork. Getting a mortgage is one of the most painful experiences you can go through. And even something simple like sending money overseas is highly expensive and incredibly slow. And the reason for this is that finance was built local first. Local banks, local branches, local services. And as that's expanded into this global financial system, the result is a badly interconnected group of islands that don't really communicate that well together, which is what causes all that inefficiency and cost. Our vision, though, is that we can build a radically better financial system, a way that makes it work for so many more people and everyone who's already using it today. And the technology is here, and that's distributed ledger technology. So what does this future look like? What is this future of finance like? Well, simply put, we believe that decentralized finance is going to eat traditional finance. And really that's because DeFi is finance built for the internet age. Much in the same way that the internet was there for information, DeFi is there for assets. And it is going to be a hugely powerful tool, which we're already seeing the starting blocks of. And the reason it's going to eat TradFi is because traditional finance and global finance in general exists for a single purpose: to efficiently allocate capital. And DeFi just does that better by orders of magnitude. And we're already seeing, despite how difficult it is to use today, things like Aave and Uniswap and other dApps and other DeFi already being used with billions of dollars of liquidity in them. So despite all the challenges, it's already getting traction and getting huge momentum. Now, I've said that DeFi can do everything that traditional finance can do. It can do it faster, cheaper, and more efficiently. But any of you in the room or any of you watching may have noticed, if you've used Ethereum, that today it's not faster, it's not cheaper. The important word, though, is that it can be. This is just like the early days of the internet, where you had an IRC channel being like, hey, we can talk to anyone in the world. It looks very different than, say, WhatsApp today. And that's kind of what DeFi is like. The possibility is there. It's just up to people to build it and giving the tools to build it to make this radically better financial world. And when we do build this radically better financial world, it's going to benefit billions of people around the world. And an incredible stat that still amazes me is the $400 trillion global financial system still only has about 30% of the world's population participating in it. Imagine if we create a system where so much more of the world can participate in that. Not only will it be good for them, but it will be good for the current use of the system as well. So this all sounds really cool. What are we going to do to make sure that this world and this future exists? And what are we doing at Radix to make sure that we create and fulfill this vision that we see? Quite simple. We aim to give people like you, builders, everything that they need in order to obsolete traditional finance. Now, what's really key here is Radix, RDX Works, we're not the hero of this journey. People like you are. Our job is just to give you the amazing tools and infrastructure that you need to build successful projects, successful dApps, and successful businesses. The Web3 version of something like Google or Facebook or anything like that to that scale will be built by people like you, and we've just got to give you the tools to do it. In short, it's about empowering you. And the Scrypto, the Radix Public Ledger, these are the tools that we're delivering to help you take advantage of the largest opportunity since the birth of the internet. So let's talk a little bit about DeFi today, because I've said some really big numbers and it can seem a bit grandiose. Like, DeFi is pretty big, right? DeFi today is about $100 billion or 0.1 of a trillion. It's that tiny dot that you probably can't even see on screen right there. Now, let's say we're super successful and we make DeFi 100 times bigger than it is today. That's about $10 trillion within the system. Again, a huge sum of money until you compare that to the global financial system. $400 trillion. And that is not including all of the additional growth that is likely to come when we have a much larger and more interconnected digital financial system. So for anyone saying, hey, DeFi's already had its boom, DeFi's already big, it's got $100 billion in it, just remember this slide. We are still incredibly early and the opportunity is huge. And to put this in perspective, just how big that opportunity is and how quickly we're growing towards it. In 2 years, and obviously the market's had a bit of a downturn recently, but in 2 years, DeFi went from having $1 billion of assets within the industry to over $200 billion. That's over a 200x in 2 years alone. It's an insane amount of money. But what's really surprising and why we're doing events like this today is in that time, the number of developers working in Web3 and DeFi had only 2x'd, up to 19,000. That is less than 0.1% of all the developers in the world. And this is despite the fact that crypto and DeFi and Web3 has had huge amounts of capital invested into it, huge amounts of media coverage. I'm sure many of you here today would have heard about crypto, DeFi, Web3 in even mainstream news. And yet still only 0.1% of all devs in the world have started building here. And what that means, and when we look at that number, is that there isn't an appetite or opportunity shortage. It's because until tools like Radix and Scrypto arrived, it was just so hard to build. And that hardness to build means that if you take the total amount of money in DeFi, divided by the number of developers working in the space, that means currently each developer on average is delivering over $11 million of value into the industry. An absolutely insane number, and a number that we want to keep growing and keep getting bigger and getting more developers in. So this takes us nicely into a bit of a background of like, if this is a great opportunity, why should you start building? Hopefully that's obvious now, but also what should you start building? And well, that's what Radix is all about, is giving you the tools that you need to be able to build this industry, build this radically better financial system. And we see what these 19,000 developers built, and we try to imagine what it would be like if we had 200,000 developers in this space. And that's what tools like Scrypto are trying to do. So if this all seems cool and abstract, and you're wondering like, how do you get started? What should you build first and what should you get going? Well, let me tell you a story about someone who has already built something, someone who's already got started. That person is Hayden Adams. For those of you who don't know, Hayden Adams was the founder of Uniswap. Uniswap is a decentralized application that launched on Ethereum and is a decentralized exchange. The reason he started this was back in July 2017, Hayden, he got laid off. He was a mechanical engineer at Siemens. And in his own words, he'd never started coding. He'd never learned to code properly. But he was looking for his next opportunity. So he decided to learn to code using Solidity. And this was in July to the October period of 2017. He picked it up, he learned it. And during this time as well, he was busy going to a whole bunch of Ethereum ecosystem events similar to what we're doing here today for Radix. And he was there to learn and to get inspiration. He didn't have an idea when he started attending these. And it was around October time that he suddenly saw a gap in the market. He saw an opportunity, had an idea. And in just 2 months, Hayden took this idea of Uniswap from an idea to a proof of concept. And that proof of concept looked something like this. And it was amazing. I mean, it's not the best UI, I will admit, but this was a proof of concept. It looked nothing like traditional finance. It was a whole new era, and you could see the beginning of what was going to be massive. I mean, it even had a unicorn in the top corner of it. Now, this is where the first bump comes, because bear in mind, it took him 2 months to go from an idea to a proof of concept, but it took him over a year to take that proof of concept to Uniswap V1 being production ready. And if you actually go and look at Uniswap, go and load up the repo on GitHub, you'll see that Uniswap v1 especially was not very many lines of code. It was not a complex application. And this is something that we've seen at Radix when we've interviewed thousands of developers, is that the number one problem with building DeFi today is not actually building the functionality. It's about making it secure. And a side note, this is exactly why we built Scrypto, to try and flip that on its head. Make it so much easier for developers to focus on the things that matter to you, functionality and creating a great experience for your customers and your users. So where's Uniswap after that point that it went live? Well, straight away, it got up to $34,000 worth of value locked in the system. Now, that is a modest amount of money, but this was an entirely new concept. Fast forward 1 year, though, and it had $20 million in the system. That is over 500xing from where it was just a year previously. Fantastic growth by any standard. But it didn't stop there. November 2020, that had gone up to 2 billion. Another 150x from just a year previously. And in 2021, it reached 10 billion, an amount of money that any tech startup would be amazed at, let alone one that only came in such a very early stage to a very early industry. So this story of Hayden Adams and how we got here, what lessons can we take from this? So the first one is that if you can already code, you're already far ahead of the curve. Hayden Adams hadn't coded before he made Uniswap. So a person with no coding experience can definitely build something incredible. Secondly, is don't worry if you're sitting here not knowing exactly what you want to build in Web3 or DeFi, because the key thing is just start learning. That's the first step. Hayden Adams didn't know that he wanted to build Uniswap when he first started learning Solidity, when he first started going to the Ethereum ecosystem meetups. But he got that inspiration, and with the learnings and with the networking, was able to deploy something great. And lastly, is that this isn't a competition. There's enough opportunity here for every single person watching this stream to found a $10 billion app on Radix. And there's still room to spare given the size of the opportunity of the $400 trillion global financial system. This industry is only getting started. And one of the things that makes me so passionate about being able to be here and speak to you today is that the founder of the first billion-dollar app on Radix could be here in this room or watching this stream today. So to close out here, I want to leave you with a thought. This is a very large mission and a very large vision. And it's a journey of 1,000 miles. And all journeys like that start with a single step. And I honestly hope that today, coming to this Scrypto workshop is the first step on that journey for many of you today. And with that, I'm going to hand over to RDX's Works' Chief Product Officer, Matthew Hein.
Creator of the Radix Ledger, and we're continuing to develop that Radix Ledger to offer features for developers and others to build what we think is a much better future. So what I'd like to talk about today is about decentralized finance and Web3 and why we think those are such critical parts of the future, and also why we think developers have such a crucial part to play in that future. So I'm going to get started talking about why DeFi and Web3 are the future, but in a way it's a future that's on pause. And I'll talk about why that is. So to talk about DeFi, and by the way, DeFi is decentralized finance, if you're not familiar with the term. To talk about decentralized finance, I need to talk a little bit about finance in general, kind of the history behind this and why the decentralized form of this is so important and what that means. So I'm going to go way back to the beginning, and I'm going to start with the beginning of finance, money. This was the very first financial technology in a way. This was money was a technology that allowed people to engage in commerce together. Without that, you're just strictly limited to barter, essentially. And money was one of the first innovations that civilization came up with. And it allowed people to interact in different ways. It allowed people to exchange goods and services and so forth like that. Of course, money on its own, just cash, is very, very limiting. It means that any given participant in this system is limited in who they can interact with. It's kind of limited in scope. They don't have reach in who they can do business with, and they're also kind of limited in, like they pretty much, you're limited by the cash that you have immediately on hand and what you can buy just today. This is a very constrained financial system. It's a very constrained economy that we can build out of this. So very, very quickly, quickly, commerce realized we needed something better than just strictly money. And this essentially was resolved with the next wave of financial technology, which was the rise of banks. This happened, roughly speaking, around the Renaissance. This was kind of the major rise of what we would consider essentially modern banking. And the purpose of this was to say, can we start bringing more than just cash transactions? Can we introduce ideas of settlement where I can make payments to people over large distances or in different economies? The idea of lending. Can I get access to capital so that I can expand my business more quickly, or I can engage in commerce that it wouldn't have been able to do with purely the cash that the cash flow that I've got on hand. Exchange is another important part of this, being able to combine together different economies, different currencies, and have that remain low friction to sort of start globalizing the economy. And then investment, of course, is the idea that, is there a way that I can put my capital to work? If I've saved up money, can I get some sort of benefit out of that? And by providing that benefit, I'm also helping feed the economy. I'm helping I'm helping merchants and other business people engage in more expansions of the business and other things that they want to do. This is speaking at very, very high level terms. Obviously, there are thousands of different kinds of financial products and services, but they kind of fit into these rough categories. Being able to do that was something that you simply couldn't do with the technology of cash. We needed the technology of the banking system, and it worked like this. It changed the nature of the relationship here. Now, an individual participant in this system is not directly interacting sort of in a P2P way with others. They trust their capital to a banking institution, and that banking institution absolutely has to keep that money safe for that bargain to make sense. And then by engaging in that bargain, the banks then have relationships with each other, which allows them to do things at a much larger scale and make a lot of these things possible that you couldn't do with just cash. Banks can have relationships that would allow me to make a payment to someone in a faraway country. It would allow me to get access to capital that those banks had collected from many different people to take out loans. It allows me to engage in investment products, all these sorts of things. So this was a technological revolution, absolutely. In fact, it's often called the first financial revolution, or various terms. And this was something that allowed, basically, commerce became global. It's interesting to think about this in Renaissance terms, but we truly did have a global economy even as far back as that. And it was all based on these relationships that banking systems had with each other that allowed people to do these sorts of things. And in fact, this was so successful, this is basically the same system that we still have today. Now, it might not quite feel like it because, like, all right, well, now I can reach, I can log into my bank on my phone, and I can do things quicker than it used to be when you just sort of having to walk into an actual bank building. But in the end, this basic bargain has been unchanged. The idea that we're trusting our capital to the banking institutions, and they are what provide the economies of scale and the mechanisms you need to be able to access all these things that drive a global economy. So this has been a successful system, but we're here in the internet age now. And the internet age has changed our expectations about what sorts of things should be possible. And this financial system has started to feel a little bit strange. And the reason for that is the internet age has trained us that there is immense power in open networks, because this created an absolute revolution in how we communicate with each other. Starting in like the mid to late 90s into the 2000s, we progressively have discovered when you have an open network, which is what the internet is, anybody can join, anybody participate, anybody can build applications that run on top of that piece of neutral infrastructure. When you have that kind of system, that kind of open neutral piece of infrastructure, it allows a rebuilding of the way things work. It allows me to, if I have a great idea for a communications application, now I can just build it and I can deploy it, and now I can reach a global consumer base. Whereas before, if I tried to build a global communications application in the 80s even, I would have had to been AT&T. I would have had to own actual communication lines that were laid across oceans and across continents. The owners of that infrastructure were the only people that essentially could provide that level of innovation. So moving to a neutral piece of communications infrastructure, a global piece of information communications infrastructure, allowed the system to be much more competitive and convenient and inclusive and cheap. It means that I can have a great idea for an application, I can launch it, I'm competing with everybody other creative applications for a world of consumers that want to communicate with each other in various ways. And so there's this natural competition that makes everything more targeted to individual user needs, it becomes more inclusive, it's competitive on cost. All these things have driven an enormous amount of innovation over the last 20 years. So when we have this kind of expectation of that, we have communication that is so competitive, convenient, inclusive, and cheap, we start wondering, well, why don't we have that in banking? And that, in the end, is the vision of decentralized finance and even Web3. It's this idea that we need to rebuild the system for ownership and identity in a way that's different. We need to start with the idea of an open, neutral piece of infrastructure where anybody can directly have their own ownership of their assets, and they have their own identity, and they participate on a completely neutral and equal basis as every other participant in the system. And once we have that piece of financial open infrastructure, now once again it allows a whole world of developers to come in and build thousands and thousands of applications that are competing for all those people's business. It allows you to build systems around ownership and identity that are more competitive and convenient and inclusive and cheap. And of course, the system has to be safe as well, because no one's going to compromise this. We need, if I am owning my own identity, or I have my own ownership of assets or money or what property or whatever it is, if I have it in this kind of system, it needs to be just as safe as the traditional banking system. And this, again, is the vision of decentralized finance and Web3. We at RDXWorks deeply, deeply believe that rebuilding a system in this sort of ground up, democratized, open, neutral way is inevitably a better way of building the system. It's going to make everything better, whether you're talking about little small pieces of friction, like, why is it so difficult for me to open a bank account? Or why does it cost $50 to send money to someone on the other side of the world? Or why is it that I can only reach certain investment products through the bank that I can get access to? There are all these little friction points that feel a little bit strange in the internet age. And our belief is the only way you can solve these problems, the only way you can move to a system where everything gets better for everyone, is to rebuild it in this more democratized, open way. So I want to zoom in a little bit. So if I kind of go back here, this is a big vision. I'm talking kind of, big concepts here, but I want to get very concrete about this. What do we actually mean? What does this open platform look like, and how is it that it can provide these things that I'm talking about? So I'm going to zoom in a little bit and talk about a DeFi network, and I'm going to talk about the 4 superpowers that these networks have, which make all of this stuff possible. So first superpower is this: tokenized assets. These networks need to have the ability of being able to turn all types of ownership of whatever type of asset class you can imagine into something that can operate on this piece of infrastructure. You basically need to bridge these things from the real world into this new form of digital world, where I, as a user at the edge of this network, can own this just as definitely as I own it in the real world, but own it in this very natively digital way. And so DeFi networks, and for those of you who are familiar with crypto or DeFi, you've probably heard of Ethereum or some other platforms that are doing this. This is one of the first things that happened on those networks, was people realized, wow, this is amazing. I can start tokenizing all these assets. Those assets might be a native digital currency like Bitcoin, where it really doesn't exist outside the network. It might be dollars or euros or pounds, where an entity has tokenized that asset and represented on that ledger, but in a way that you can be confident that you can then redeem that for the digital version for something else that you can take with you in the physical world. It might even be things like equipment that you win in an online game, the awesome sword that you won at the end of a raid, or the skin that you won because you reached a certain level. All that stuff is a different form of ownership that we'd like to have on these same kinds of networks. It could be things as boring as contracts that you would have, sort of, a representation of a relationship between two parties. Or for those of you that have been into NFTs recently, it might be like a unique digital avatar that I can use on Twitter or something else like this, where only I own it within that particular world. So these are all different types of tokenized assets. And the first feature that we need is that ability to create those assets and have them be managed in a very secure way. Second superpower is this. is dApps, or smart contracts. dApps basically just means decentralized application. It basically means an application that's interacting with one of these types of open decentralized networks. So, and the heart of a decentralized application is the smart contract. And I'm going to talk a lot about smart contracts. I'm going to get into detail on this. But basically, it's a piece of code that's running on the same network that you've tokenized assets. It's not sort of a secondary thing. The same network that understands, oh, yes, this is a tokenized asset, needs to also be able to run logic that developers can bring into those networks to make these things programmable. Those two things together, just those two superpowers, are quite powerful. If you have tokenized assets and you have the ability to write logic that can interact with those assets, now we can start talking about real financial products. So to take an example, let's take something that we're all pretty familiar with. I mean, if you've ever gone through an airport, you've seen 100 different currency exchanges, and there's some company or bank behind that, and they basically say, you can walk up to this kiosk, we've got a bunch of money back here, you hand us some currency that you want to trade, we'll look up a market rate, and then we'll go back to our reserves and we'll pull the equivalent amount and we'll give you euros back or whatever it is that you asked for. So it's kind of a simple interaction, but there are whole banks that need to exist to provide this kind of service. It's not trivial to be able to do that kind of thing, even though the transaction itself is quite simple. And the cool thing is we can rebuild this on a DeFi network. In concept, it could look something like this. The idea, we can imagine, it's like, all right, I, as the person that wants to do the trade, I have some kind of account on that system, and that account can hold some tokens that mean maybe dollars or euros or something. So let's say I've got token A and token B. So basically what I want to do is I want to be able to send some of token A into some piece of logic here. There's some sort of trade function that this logic provides. I send the tokens in there. It does some calculation and figures out, oh, okay, current market price based on blah, blah, blah is this. And I'm going to now take some token B out of my reserves, and I'm going to send that back to you. If we have the assets and the logic on the same network, then, and we have the idea of I can own things on that network, we can provide this. Anybody can write this code in a relatively short amount of time, put this on the network, and you have basically a currency exchange. Now, I'm going to get a little later into the complexities that actually come when you try to build this sort of thing. But in concept, we have the superpowers that we need to start building blocks of finance. Okay, but there's a couple more I want to go through. So let's talk about superpower 3. So if we have tokenized assets and we have smart contracts, the next thing we need is composability. And this is a really important concept to understand, particularly as a developer. It's the idea that it's pretty limiting if all I can do is just have one piece of code that's doing one particular thing. What I'd like to be able to do is to say, there are other pieces of code on this network that do very specific things, and I want to be able to combine these things together. And so it might be that maybe in order for me to do a currency exchange, I actually am then going to go off and there's somebody else that can provide me a loan that allows me to get the liquidity I need to be able to complete that exchange for something. This is basically how the real financial system works today, where there are all these relationships and multiple levels of system where in the end, the user experience is maybe one application or one financial product, but behind, there's this sort of hierarchical stack of products and services that are behind that. We need to be able to replicate that kind of flexibility and power in a decentralized network. So composability is what allows us to do this. The idea that on this network, can we allow these different applications to talk to each other and coordinate what they're doing? Okay. The last superpower is this, and this is also a really important one to understand. It's the idea of two-sided markets. So any financial transaction that you can imagine pretty much almost always has two sides to it. There's a buyer and a seller. There's a maker and a taker. There's a lender and a borrower. Or yes, lender and a borrower. So there's always, basically, there's someone that has something that the other person wants, and there's an exchange that happens there, or I'm providing the capital that makes this thing possible for the other person. There's always something there. Now, in the traditional financial system, one side of that was, in almost all circumstances, a bank, of course. They had the capital, they had all the systems, they had all the relationships, and so the idea is you go to them and say, hey, I'd like to exchange some currency, or I'd like to take out a loan, or I'd like to invest in something, and they provide that for you because they have the other side of that market. One of the really powerful things about an open, neutral network for doing this kind of thing is that now both sides of the market can be individual people. So just like I might want to go and say, well, I'd like to do a currency exchange with this. Well, to do that currency exchange, this piece of this application code needs to have some reserve of tokens that it's trading out of. Well, where does that come from? It can come from other people. Other people say, look, I've got some money. I'm going to lock that money into this exchange application. And I can trust that application is going to operate properly. And so every time a trade happens, maybe there's some fees that come out of that. And those fees get shared with me because I've provided some of this capital. Now, rather than having one bank that provides that capital, now 1,000 different individuals can put in $5, $10, $1,000, whatever it is, and proportionally receive some of the benefits of providing that capital liquidity for other people. That pattern repeats itself over and over again in decentralized finance in the very early forms that it's in today. It's the idea that virtually any application is both sides of the market being provided in this very democratized, crowdsourced sort of way. It's immensely powerful, and it's also immensely empowering. It means that we can all participate in these things rather than these things being essentially locked up by monopolies. Okay, so with these 4 superpowers, we now have all the tools we need. We can now tokenize a world of assets, whether it's digitally native assets from games or from currencies or digital cryptocurrencies or NFTs or whatever it is, or we can bridge in dollars or euros or real estate or whatever it is. We can tokenize all that stuff onto a network, and we can write code that can interact with that stuff and can basically then recreate functionality in very powerful ways. The applications that you build might be, kind of boring financial applications like a currency exchange or options and derivatives or lending or all those sorts of things that you would get from a bank. But the other cool thing about this is this network doesn't really care about what your application is and what these assets mean. It's just this really powerful piece of functionality. So you can use the very same tools for video game economies. You might have an online game where you want to have every bit of the financial power that you have from a bank. It's like, yep, I have a game where I actually want to engage in lending, or people are carrying around swords and gold or whatever it is, and I want people to have a real sense of ownership of those assets. You can use these sorts of DeFi networks to build gaming economies around it in a real sense of, I have a real identity, I have a real ownership of these things, just as much as me holding dollars and credit cards in my wallet. And have that interact with gaming economies. It could also be things like digital twins of whole cities that can sort of, model how cities behave and have real ownership of various parts of data that come out of IoT devices or whatever it is. There's a world of applications that often may not feel like finance, but really they all center around this idea of truly natively digitizing ownership and identity and allowing us to programmatically interact with those things. This is unbelievably powerful. And this is what we think we need to start to rebuild how things work. And this is what's behind decentralized finance, but also Web 3.0. When people talk about Web 3.0, at the deepest notions of this, it's basically about the idea of bringing real asset ownership and real identity to the web. It's the idea that I'm not just logging into a website and trusting that they're going to do something on my behalf. It means that I can really bring my own person, I can own ownership of my own identity and real assets and have applications on the web interact with those things. It's the same general concept. In fact, I would even argue that the metaverse is part of this concept as well, this idea of bringing virtual worlds together and having those feel very tangible. So basically, these are the 4 superpowers that we need to go from finance as it's been for the last 300 years or so to decentralized finance, Web 3.0, or the metaverse that's built for the next 100 years or more. So you might ask yourself, well, that's amazing. There's clearly enormous potential here, and you'd be absolutely right. This is a gold rush for developers to come and say, look, man, we can now access this piece of infrastructure and we can start building these applications and solving a million different problems for people with an advantage over traditional systems. But as you've probably seen in some of our other materials, you can see that even though there's a $400 trillion opportunity for global finance, which is just mind-bogglingly large, it dwarfs any other sort of market opportunity you can imagine. DeFi as it is today is very tiny. We've talked about this in some other videos, so I won't belabor it. But basically, on this chart, it's a invisible pixel compared to this big blue square. So it's obvious to ask, well, why is that? If there's all this potential here, and if we have networks that can provide these 4 superpowers, why isn't this immediately exploding? And to answer that question, we have to come back to the reason why we care about these networks. It's the idea that we want solutions that are more competitive, convenient, inclusive, cheap, and still as safe as we're expecting from the banking system, or better. And the problem is that DeFi, even though Ethereum and platforms that can do this today, they don't do it in a way that really delivers on these values. You can kind of think of it as like the prototype form of it. Like we can start building applications on these open networks, but if that network isn't good enough various ways, the end solution is still kind of hobbled a little bit. It's held back. We're in the very, very early phases right now where DeFi is all about just exploring the possible. It's like, oh my God, we can actually build a lending system or Web3 based games where people can own stuff on these ledgers. You can do this stuff, but the problem is right now for the platforms that exist, it's kind of slow to build those things. It's very difficult to write that code. It's very difficult to guarantee a high level of security of that code. So there frequently are hacks where honestly millions of dollars run out of these applications. The fees to operate these networks are often quite high because the bandwidth essentially they can handle is quite low. And so all of these attributes that we would like to have, that we believe these networks can provide, aren't actually being provided yet because the platform itself isn't good enough. And so this is what RDX is really about. And so the last thing I want to talk about here is the problem with smart contracts today, because our belief is that the most important problem, not the only problem by any means, but the most important problem that's holding back DeFi from reaching its potential, from holding back developers from being able to go after this potential, is the fact that the way smart contracts are built today, even though they basically have these 4 superpowers, just aren't good enough. And so I'm going to talk a little bit about what I mean by that. So smart contracts, I've talked a little bit kind of at a high level of what it means. I'm going to get down to just a little bit more level of detail. If you think about a generic smart contract environment, what does that mean? It's essentially a shared computer. You can really think of it. It's sort of like a mainframe. It's like you can think of this box as like, here is a great big computer, which is sort of running in this distributed way out in the cloud across many different validators and so forth. Basically, in the end, from a developer's point of view, you can deploy a piece of code to that shared computation environment, and the network will happily compute things for you. You can load your program, you can run your program. That basically is a smart contract. It's just a piece of code that runs in this shared distributed environment. But that alone isn't quite good enough. That doesn't give us all the superpowers we're talking about. We need one more feature at least. And that feature is what I would say is messages, basically. You need the ability of these applications connecting to each other. And this essentially is the model for the Ethereum virtual machine. When you think about that computing environment, when you're deploying a smart contract to Ethereum today, you're basically loading it into what we call the Ethereum virtual machine, or the EVM, you'll hear it referred to. And this is basically what the EVM does for you. It says you can run programs here, and those programs can talk to each other. And with that, you can do the 4 superpowers. You can have, for example, if you want to tokenize an asset, I can write a piece of smart contract code that says, all right, I am going to keep track of the balances of various account addresses. You know, basically, you can sort of take a cryptographic key pair that represents a person, and I can have entries for the public key in this list of balances. And so you can talk to my smart contract and say things like, please send tokens from Alice to Bob, and I'll change my internal balances. And that kind of simulates the behavior we expect for assets in the real world. It's like, oh, okay, this simulates the idea of me handing an asset from one person to another. And so if you've heard about ERC20 contracts or various types of token smart contract, that's basically how it works, is you have these individual smart contracts that create token-like behavior. And then we can also talk about things like currency exchange. You can imagine another one of these smart contracts which implements the idea of swapping between 2 different currencies. And that, of course, means that to do this, you have to talk to other smart contracts that represent the tokens themselves. So you have this sort of coordinated action between multiple smart contracts. So this works. This is what DeFi is built on today. But in our opinion, this is an oversimplistic model. It was V1 of the smart contract concept. And very quickly over the last few years, we've learned the limitations of it. The limitations are it's very difficult to write code in this model. It's very complex to guarantee security. The code is very complicated because you have to do all this coordination. So the problem, ultimately, to distill it down, is this was the idea of swapping that we'd imagine. I'm just going to go ahead and call this Uniswap. Uniswap, by the way, is the most popular application in DeFi today. It basically is that currency exchange, but on an open ledger. And I think you've probably heard the story of Hayden Adams, the creator of Uniswap. Uniswap should look like this. It's just the simple idea of I've got some tokens, I send them in, I get some other tokens back. The problem is, in reality, the real version of Uniswap that's on Ethereum today looks more like this at a system diagram level. It's the fact that, okay, I have this big piece of smart contract code, which needs to do multiple calls to individual third-party smart contracts that are implementing individual tokens. I need to sort of maintain my own cache of the balances on those things, because you can't necessarily rely on each one of those token smart contracts doing the right thing. Someone might have written a bad smart contract for a token that does something malicious or something just accidentally bad, so you need to very carefully interact with these things. So the system becomes, even for something as simple as doing a token swap, it becomes this fairly complicated thing. And this is why it took Hayden Adams something like 18 months to get from an idea to a deployed application on Ethereum, something that he was confident we could actually hold money for a large number of people. So we've asked ourselves at RDX Works, the question is, how do we let Hayden Adams build Uniswap in a day? Uniswap in concept is a very simple thing. What are the tools? What are the changes that we need to make at a platform level to make it so that something that simple can really be built as simply as you'd expect it to be? And that's the basis of what we call the Radix engine. Radix engine is our virtual machine, essentially. It's our replacement for the EVM. EVM is the concept that basically virtually every crypto DeFi network today is using. We've gone a very different direction with it. And the primary thing that we've added is we've kept the features that you had before. You still have this idea of computation. You still have this idea of messages. But we've added this new concept of resources. It is a platform level concept. And the idea here is, if the entire idea of DeFi and Web3 and the metaverse is the idea of ownership of assets and identity, well, why isn't it the platform understands that natively? Why is it that we have to implement that at the smart contract level? Why isn't it that I can't just go to the platform and say, yes, I would like to have an asset and be guaranteed that it's going to behave in an asset-like way, universally across the platform? No question of bad implementation of token smart contracts or anything like that. And so we've implemented this with a very specialized bit of finite state machine code that provides these very hard guarantees of asset-like behavior, and yet provides an enormous amount of flexibility to the developer to define what type of asset are we talking about and how should it intuitively behave. And you'll get quite a bit more about this once we get into details of Scrypto and how it works. But this is the fundamental application difference that we've made at the platform level. And what this means in the end is that Uniswap can actually look like this on Radix. It's the idea that I can have natively understood the idea of token A and token B, and a trader's account can be a real thing that can actually hold tokens in it, and the platform understands that idea of ownership, and the idea that interacting with this code means I can just totally focus as a developer on saying, I want to accept token A, I do a little calculation, and then I send back token B, and I can actually have little token pools in here. We're going to talk about in some of our other materials about how it is you're going to build that, but you'll see that it's so much more intuitive and direct. And in the end, this is what Radix Engine and Scrypto are about, is taking this idea of DeFi and finally expressing it in a form that allows any developer to pick this up and really participate in rebuilding the way ownership and identity and finance are done in the world, and in the end to change the way the entire world works. So we're really excited about it. We hope you're excited about it. And we'd love to talk to you more about how you can actually start writing code and getting stuff built in this new world. So thanks very much for listening.
Hello everybody, I am Omar and I am a developer at RDX Works. You've heard from Adam and Matt about the importance of DeFi. I will now give you an introduction to Scrypto. Scrypto is the programming language that we use to build decentralized applications or smart contracts on the Radix platform. So let me give you a quick rundown of how this presentation is going to flow. I'm going to begin by giving you a quick overview of some of the Scrypto concepts that we have. And then I'm going to move over to a Scrypto demonstration. I'm going to be doing live coding for an example. It's going to be a token sale example. I'm going to show you how we can take this idea of doing a token sale and actually representing it in actual Scrypto code. We're then going to do a Q&A session, just so that if you have any questions or anything or something that isn't clear, I'll be here to answer it. And then we're going to have a challenge at the end where you're going to be building something. So stay focused. If you have not installed Scrypto, I have a QR code on the right-hand side here. This QR code is going to take you to our documentation, and the documentation has very, very detailed instructions teaching you how exactly to install Scrypto and how to get Scrypto up and running on your local machine. So with that, let me actually begin my presentation. If you've programmed on other blockchains in the past, you know that in order to have a token on that blockchain, you oftentimes need to implement a smart contract that defines the idea of a token, that defines the idea of an asset. And the smart contract essentially says, we're going to have some kind of balance sheet, and on this balance sheet, when we want to transfer tokens, we do this little operation, and when we want to mint tokens, this is what we do, and when we want to burn tokens, this is what we do. And so you find yourself implementing the idea and notion of a token all by yourself. But with Radix, we decided to take a completely different approach. With Radix, assets and tokens are native to the ledger itself. It is native to the Radix platform itself. And so this means that the platform understands how to transfer, mint, burn tokens. It understands that tokens have a supply. It understands that these tokens can be moved. It understands that these tokens could be taken away from you at some point of time. And it understands all of these different things. And we don't exactly call them tokens or assets. We actually call them resources. And so the name resources is the name that you're going to see in Scrypto. It's the name that you're going to see in the community. It's pretty much the name that you're going to see everywhere. And so I want to give you like a quick summary. Resources are essentially tokens and assets. And the way that we implemented resources is through a finite state machine, which I'm going to talk about during this presentation. There are two main types of resources that we have, which is fungible and non-fungible resources. Fungible resources, as you may know, are interchangeable. 1 unit of a fungible resource is equal to 1 unit of the same fungible resource. Non-fungible resources are a little bit different. They're different in the sense that they are individually unique, individually addressable, and each of them have individual metadata. And so each non-fungible resource in a bigger non-fungible resource is individually unique and addressable. And resources always live in resource containers, and these resource containers can either be buckets or vaults. The idea of buckets and vaults share a lot in common. For starters, they are both resource containers, meaning that both of them store resources. And both of them only hold a single resource address at a time. And so what this essentially means is that you can have a bucket of XRD, a bucket of Bitcoin, and another bucket of Ethereum as an example. But you cannot have a bucket of XRD, Bitcoin, and Ethereum. This is not something that we support, and this is not something that you should do. A bucket should only hold a single resource address. So this is what that part means. But buckets and vaults are a little bit different. Buckets are meant to be temporary and transient. Buckets only exist for the period of the transaction. Once the transaction finishes, buckets cease to exist and no longer exist. Vaults, on the other hand, are meant to be the permanent version of resource containers. They are permanent, they cannot be deleted, they cannot be removed, and after a transaction finishes, a vault is going to remain. And vaults are stored inside components. I haven't talked to you about components just yet. We're going to talk about them in a little bit. Just know that vaults are stored inside components. So quick summary, buckets are temporary and transient, and buckets only exist for the period of a transaction. And then after a transaction finishes, buckets cease to exist. Vaults are permanent and stored inside components. And so here's a diagram that can sort of illustrate the relationship between vaults and buckets. Let's say that we have two components, and each one of these components has a vault. Let's say that the component on the left wishes to send some funds to the component on the right. And so what it does is that it takes some funds out of its vault, it puts them in a bucket, and then it passes this bucket to the other component. The other component takes this bucket and then empties it in its own vault, and the transfer of tokens is completed now. And so now that I've talked to you about buckets and vaults, I can finally talk to you about the finite state machine that resources are implemented through. And so one of the questions that you might have is, why exactly did we implement resources through a finite state machine? Well, there are so many different advantages to this approach, and perhaps the biggest of which is transparency. And what I mean by transparency is this. Since this is a finite state machine, you can essentially query the blockchain or query the ledger to see how this resource behaves. And so you can essentially query the blockchain and say, how is this resource going to behave? Is this resource mintable? Is it burnable? Can this resource be taken from my wallet at some point of time? Can the person who created this resource all of a sudden say that this resource is all of a sudden going to be soul bound and you can no longer withdraw it? So it offers all of these guarantees, and it gives you a way to be able to say, I know how this resource is going to behave at the current moment of time, and I know how this resource is going to behave in the future. And so it offers a great deal of transparency to you. So you no longer have this idea of an ERC20 token that is almost functioning like a black box, and you have this transfer function that maybe it does transfer, maybe it doesn't, who knows. Resources are very transparent, and they offer a great deal of reliability. And let me sort of give you an introduction or a quick overview of this finite state machine and how to think about it. And then we're going to tie all of these ideas into code. So when a resource doesn't exist, it comes into existence by being minted. And if you remember what I talked about with buckets are the temporary resource containers. So when a resource is minted, it goes into a temporary resource container, which is a bucket. And then since this is temporary, it has to go somewhere. And so that somewhere could perhaps be a vault in some component, and then it could be taken out of that vault into a bucket, perhaps put into another vault in another component, and maybe then taken out of that vault into a bucket. And then perhaps we're done with that resource, we no longer need it, and then we can burn this resource. And so this is the finite state machine that implements resources. And so looking at this, you might ask, well, how exactly do I customize the behavior of a resource? I mean, let's say that I would like this resource to only be mintable by me, or let's say that I want to be the only person who can deposit this resource, or something like that. Let's say that I want to modify the resource behavior in some kind of way. Well, the way that you modify it is by controlling who can perform the transitions on this finite state machine. And so as an example here, let's say that you want to say that nobody can deposit this resource except for me. So you say nobody can perform the state transition from a bucket to a vault except for me. And so this is what we call a restricted deposit resource. And so we've got these methods in Scrypto that allow you to customize all of this. And so the mintable and burnable allow you to set the rules for the state transition on the minting and the burning of tokens. Essentially, it allows you to say who can increase the supply of that resource, who can reduce the supply of that resource. Restricted withdraw and deposit are self-explanatory. They let you control who can withdraw and deposit that resource. Updatable metadata lets you control who can update the metadata of that resource. And so as an example, it lets you control who can update the name, the symbol, and all of these different things on that resource. And then we have something else called recallable, which we have not implemented in Scrypto as of yet, but it's one of the things that we want to implement in the future. Essentially saying who can take this resource out of your own vault forcefully. And there's a lot of use cases for this recallable thing, which we can get to at a later point of time. So we've talked about all of these concepts, and these are really cool concepts. So let's see how these concepts tie into actual code. And what I'm trying to do here is that I'm trying to show you that all of these things are not some sort of theoretical, abstract concepts that you never get to see. These things do actually exist in Scrypto, and these things are things that you're going to be dealing with on a daily basis when you begin programming in Scrypto. So the code that you have right here is code that creates a new resource. And let me quickly go through what this code is doing. We are going to a struct called resource builder, and we're telling it that we want to create a new fungible resource. We're providing some metadata on that resource, and then we're changing the resource behavior a little bit so that we say that we are the only people who can mint it, but anybody can burn this resource, and then we're specifying some initial supply. So how exactly does this code relate to all of the stuff that we discussed previously? So let's dissect this a little bit and go through it one by one. The first thing here, if you remember, I told you that there were two main types of resources: fungible resources and non-fungible resources. Well, this is exactly where the coding thing happens. When you want to create a fungible resource, you go to the resource builder and you say, I want to create a new fungible resource. And if you wanted to create a new non-fungible, it would just be resource builder, new non-fungible. And so this is where the two resource types come into play. In addition to that, if you remember on the finite state machine that I talked about, I told you that when a resource gets minted, it goes into a bucket, which is a temporary resource container. And this is exactly what we see. When we create the resource for the first time, when we mint this resource for the first time, it does indeed go into a bucket. And so you get to see the theoretical part in actual code. And so the finite state machine is actually, you can sort of see it in code. And then last but not least, this is how we get to sort of define who can perform the state transitions in code. And so over here, I'm getting to say that the mintable, and so only somebody who is in possession of an admin badge is able to mint this resource, but anybody who has this resource can burn it. And so increasing the supply of this resource can only be done by an admin, but reducing the supply of the resource can be done by anybody. And we can modify this if we think that, hey, we only want admins to be able to burn the supply of this resource. We can modify this to make it that way. So earlier I told you that vaults live inside components. So what exactly are components? Well, if you've programmed in any other smart contract framework in the past, you can think of a component as what Ethereum calls a smart contract. It holds state, it holds data, it has methods and functions, and it is essentially what you call for most operations. But a component does not really have any logic in here. All of the logic is stored inside the blueprint. And so if you've programmed in any object-oriented programming language, the relationship between a blueprint and a component is going to be immediately clear to you. You can think of a blueprint almost like a struct or a class, and then a component as being an object of that struct or class. And so this is the relationship that they have. And so blueprint defines the general structure that components will follow. It defines how many vaults we're going to have. Again, to recall, vaults are the permanent resource containers, and so it defines the permanent resource containers that components are going to have, and it defines the data that components will have, it defines the methods, and it defines the functions, and it defines the logic behind all of these methods and functions. And then components can be instantiated or created out of that blueprint. And if you have multiple blueprints in a system, we call that a package. And so packages are addressable, components are addressable, but blueprints are not addressable. And we'll get to see this a little bit more in code once we get into the demo. And you might be asking, where exactly is this idea of blueprint component going to be helpful to me? Well, let's say that you've decided to embark on this journey to build a decentralized exchange. And for simplicity, I'm calling this decentralized exchange Uniswap, since this is the most well-known name in the industry. And so let's say that you've embarked on this journey to build Uniswap on Radix. And so Uniswap on Radix is going to need to have multiple liquidity pools, and these multiple liquidity pools will essentially be multiple trading pairs. And so you want to have one trading pair for XRD BTC, and maybe you want to have another trading pair for XRD ETH, and maybe you want to have a third for, I don't know, BTC ETH as an example. And so the way that you can model this in Scrypto is by first coding a pool blueprint, and the pool blueprint is going to define the different vaults that this is going to have. It's going to define the data that the components are going to have, and it's going to define the logic. And then out of this blueprint, you go and you instantiate multiple different components. And so in here, we created one component for the BNB XRD pool. We created another component for the ETH ADA pool, and another component for the XRD BTC pool. And so this is how the blueprint component relationship is useful. You can essentially, you have this one blueprint that you can use for multiple different things when you need it. So we've talked about many different things, and maybe you have this question of, well, where exactly do accounts tie into all of this? Because we haven't talked about accounts yet. Well, accounts are just components. Accounts are special components instantiated from a special blueprint called the account blueprint. And the account blueprint essentially defines that an account has multiple vaults, an account has withdraw and deposit methods, and it has multiple other methods that are useful for what the account does. But an account is essentially just a very simple component. Nothing special about it. And there's this other concept that we have in Radix, and this is, I can spend hours talking about this, which is the concept of transaction manifests. Transaction manifests allow you to compose multiple things in one transaction. So let's go through a very simple example of a transaction manifest, and then I'm going to give you a bigger example of the usefulness of transaction manifests. Let's say that we have two accounts, one belonging to Alice and another belonging to Bob, and let's say that Alice wishes to send Bob some tokens. What Alice can do is that she can define a transaction, and the transaction says withdraw some funds from Alice's account, and then take these funds and deposit them into Bob's account. And so this is a very simple example of a transaction manifest. But a transaction manifest does not have to be this simple. A transaction manifest can be as complex as you wish for it to be. And so you can have a transaction manifest that says, go to Aave, take a flash loan, and then go to Compound, take a loan, and try to deposit stuff into my account, and then try to do this governance thing, and then it can define a lot of things that happen in one transaction, and all of these things have to happen atomically. And so all of them either succeed or all of them fail. And so it's a very, very, very powerful concept, and I can have like an entire hour presentation talking about this one concept alone. Really, really powerful concept. So enough theory, let's get into actual code, which I think many of you are excited about. So what I want to be building today is a very simple thing, and we're going to build it in multiple stages. I would like to build a token sale blueprint. And so this token sale blueprint would allow people to call the blueprint or to call components of the blueprint saying, hey, I want to buy some tokens that you created. And the blueprint does some math to determine how much tokens it can provide at the current price, and it returns some tokens back to the caller. It is a very, very simple blueprint, but a very powerful blueprint as it gets to show you a lot of different Scrypto concepts in practice. So let's define what we would like to build for the first demo. For the first demo, we're going to build, let's say, the skeleton of the blueprint. What we're going to do is that we're going to build a very simple blueprint that has a single function called new. The new function is going to create a new resource for us, and we're going to define a blueprint that has a single vault that's going to hold some tokens. And so I told you that we're going to be doing a token sale, and in this token sale, we're going to be creating a new resource. And so, let me scroll up. Yeah, and so in this token sale, we're going to be creating a new resource. I am not very creative with names, and so the new resource is going to have a name of useful token just because I am not creative with names whatsoever. So this will be the name of the resource, useful token. All right, so let's begin coding and let's get to see this in practice. So I'm going to come here and I'm going to open my terminal. And so the way that you create and use Scrypto code or begin coding in Scrypto is by using the Scrypto new package command. So I'm going to do Scrypto new package. So what we need to do now is to give this package a user-friendly name. Again, I'm not creative with names, so I'm just going to call it token sale. Let me open that up in VS Code. Make this big. And if you're somebody who is familiar with Rust, the folder structure that you see here is immediately going to be familiar to you. You got a cargo.toml, you got tests, you got source. This is because Scrypto is actually built on Rust. It is a Rust framework. And so all of the concepts that you know from Rust are transferable to Scrypto. If you use some extensions with Rust, they can be used with Scrypto. And so it is a Rust framework. So let's go to the source folder, and we're going to find a lib.rs. And this is the boilerplate code that you create when you first create a new Scrypto package. It's a hello world example that creates a new resource. But what I'm more interested in is doing some live coding. So I'm going to delete all of this, and I'm going to begin from the very, very beginning. So I'm going to leave the first line here, which is use Scrypto prelude, and then the star. This is essentially importing the Scrypto standard library, and it's saying, get me everything in the Scrypto standard library. I wish to use that. And so we said that we want to build a blueprint of some sort. And the way that we define a blueprint is by using the blueprint macro. So that is blueprint exclamation mark and then 2 curly brackets. And a blueprint is comprised of a struct and an implementation of that struct. So let me go ahead and do that. And again, I'm not very creative with names, and so I'm going to call my struct token sale. But you can call it whatever you want. Naming is completely up to you. So struct token sale, and then the implementation of that struct, which is token sale. Fantastic. So now we have a bare bones blueprint. This blueprint is quite boring, if I'm being honest. It has no state, it doesn't have any implementation, doesn't have any functions, does not have any methods. It's quite boring and it really doesn't do anything. So let's begin adding more functionality to this. So if you remember, I told you that we're going to be creating some resource and we would like our component to store that resource. So we're going to need a permanent resource container, which is a vault. So I'm going to define this up here. I'm going to call this useful tokens vault, which is a vault. So we've defined a vault in the blueprint state. And so whatever components created out of this blueprint are going to have one vault. So let's now go ahead and define the constructor. So again, in true Rust fashion, the constructor is a function that you call to instantiate or to construct a new object. In this case, the constructor is a function that you call to create a new component on the blueprint. And let me call this function new. So I'm going to write public function new. And we're going to need this to return a component address. All right. So let's actually begin doing this. We would like to now create a resource. And this will be the resource that in later demos we're going to be selling. And so if you remember the example I showed you earlier, resources can be created through the resource builder. So let's go ahead and do that. I'm going to say let bucket of type bucket be equal to resource builder. And then let me do new fungible. And let me create the most boring resource in the world. First, in the beginning, I'm just going to create the most boring resource in the world, but I'm going to make it a little bit more exciting later on. So new fungible, I'm just going to define an initial supply of 1,000. All right, again, this resource is quite boring. It has no identity, it has no name, it's got no symbol, it's got nothing. So let's actually go ahead and give it some exciting metadata. So let me do this, metadata, I'm going to give it a name. I'm going to call it useful token. And again, let me give it another metadata of symbol, which I'm just going to call useful. And now we've created a pretty exciting resource. The resource that we created is a fungible resource. It has a name and a symbol as metadata, and we have an initial supply of 1,000 of this resource. All right, fantastic. So now that we've created this resource, let's actually go ahead and create the component. If you remember, the new function is a constructor. And in the constructor, we need to actually construct the component that we want to have. So the way that we do that is by calling self with a capital S, useful tokens vault. And I'm going to just call vault with bucket. Then I'm going to instantiate and globalize this. Perfect. So now we have our very first blueprint. The blueprint defines a single vault that's called useful tokens vault. There's a single function in this blueprint called new. It returns a component address. The function creates a new resource for us, and then it instantiates a new component. So what we've built here is it's a pretty cool thing. We've created a new resource, and all of this is cool, but this is not very useful. We want to build a token sale. We want to be able to accept tokens or accept XRD, and in exchange for this XRD, we want to return some tokens back. So let's actually go into demo 2, where we're gonna build more, or we're gonna extend this blueprint that we have into something that is bigger. And so token sale. Let's actually implement a basic token sale. So for a basic token sale, we need to have some data that defines the price per token. And we're going to need to have a method that allows people to buy these tokens. And so this method is going to accept some XRD, and in return for this XRD, it's going to return some tokens. We're going to need a permanent resource container or a vault that is going to store these tokens, or that's going to store this XRD. And so this is what we're going to be building now. And so let me actually go back into code and then begin implementing this token sale. All right. So the first thing that we're going to need is some vault where we're going to store the XRD that people are going to pay us. So I'm going to create it, or I'm going to define a new vault at the top here, which is called XRD tokens vault, which is a vault. And then since I have a new state variable defined up here, I'm going to need to put it here when I create that component. So I'm going to say XRD tokens vault, which is vault new Radix token. And so in here, I would like to create a new empty vault, and this empty vault is going to store XRD tokens. In here, I did not need to use the new function because we have a bucket, and we can straight away sort of figure out what the resource address is based on the bucket that we have. Awesome. So now that we have the XRD tokens vault, let's now allow the instantiator of the component to set the price of the tokens. So we're going to have a new argument on the new function called price per token, which is a decimal. And so again, the price per token is the price of these tokens, how much they cost, so that we can determine how much we give back to the caller. And we're going to need to store this in the component state at the top, so we can actually access it when we call the buy method. I'm going to say price per token is a decimal. All right, and since this is being passed, we're going to need to give it to the actual constructor. So let me do price per token is price per token. All right, so let's actually go into the interesting part, which is implementing the actual token sale. So I'm going to implement this through a function called buy. I'm going to explain this bit once I write it down. So what does all of this mean? We've defined a new function called buy, and it takes a mutable reference to self. The reason why it takes a mutable reference to self is because in Scrypto we have two different concepts, a concept called functions and another concept called methods. New is a function as it does not require any component state. Buy is a method as it requires component state, and so it requires a reference to self. And buy requires a mutable reference to self because we're going to be putting XRD in the XRD vault, and we're going to be taking tokens out of the useful tokens vault. And so this is why it needs to be mutable, because we're going to be mutating the actual component state. All right, fantastic. So now that we have this, we have an argument here called funds, which is a bucket. This will be a bucket that the caller provides, and that bucket is going to be a bucket of XRD. This bucket is going to contain the amount of XRD that the caller wishes to use to purchase some of our tokens. And in response to this, we're going to be returning a bucket. And again, that bucket is going to contain some useful tokens. And so you can think of it this way. We take XRD, we return useful tokens. So this is how you can think about it in a really simple way. So now that we have this funds bucket, let's calculate how much tokens this translates to. I'm going to say let purchase amount, which is decimal, be equal to funds.amount divided by self.price per token. All right. So what we're essentially doing here is saying, with the funds given to us and the current price, how much tokens can we give back to the caller? And based on the calculation that we did, we're going to take the XRD that the person has given us, and we will put it in our vault. And then we will take the purchase amount from the useful tokens vault and return it back to the caller. So I'm going to do self.xrd tokens vault dot put funds, and then self.useful tokens vault dot take the purchase amount. And this is it. So we've implemented a very, very simple token sale here. Let me do a quick recap of what we have. Sorry about that. We have a method called buy that takes a mutable reference to self. It's a mutable reference because we are putting funds into the vault and taking funds out of the vault. The caller of the method gives us a bucket of XRD, and we return back to them a bucket of useful tokens. Based on the amount of funds available to us, or based on the amount of funds that has been sent to us, we calculate how much that translates to based on the current price. We take the XRD sent to us and we put it in our vault, and then we take some useful tokens out of our vault corresponding to the purchase amount and return them to the caller. Fantastic. So let's actually get to see this in practice. I want to actually run this and show you this thing working. So I'm going to open my terminal down here. And if you want to know how you can open this terminal down here, you can go to the top terminal and think it's new terminal. Yeah, it's new terminal from the top. And so part of the Scrypto tool chain that you have installed, part of it is a tool called Resim, or Radix Engine Simulator. And so the Radix Engine Simulator essentially allows you to simulate the Radix engine and simulate how it works. So the first thing that I'm going to begin by doing is that I am going to reset the entire state of the Radix Engine Simulator by doing resim reset. And what I'm going to need to do now is that I'm going to need to create an account which we're going to be using for all of the method calls that we're going to have. And I do that through resim new account. Fantastic. So now I've just created a new account. And if you remember from the presentation earlier, I told you that accounts are just normal components. And so as you can see here, the account that we created has a component address because it is just a normal component. It does also have a public key and a private key. And so what I would like to do now is to take this package that we have written and publish it to the local simulator. So let me do resim publish and then dot. So dot essentially means I would like to publish everything in the current directory. So that compiles everything for me. Then it will publish it and give me a package address. All right, fantastic. So now we have a package address. If you remember from the presentation earlier, I told you that components are addressable and also packages are addressable. So this is what I meant by that. Packages do indeed have an address, which you can use whenever you're calling a function or things of that sort. So now that we have this package address, what we would like to do to create a new component is to call the new function on the token sale blueprint. And so we can do that again by using resim. So I'm going to do resim call function. And the call function subcommand takes a few arguments. If you're a little bit unsure about the arguments that it takes, you can just call resim call function and it's going to tell you that it requires a package address, requires a blueprint name, and requires a function name, and also whatever additional arguments. So I'm going to do resim call function. As it says here, it requires a package address. So I'm going to provide it with that. It requires a blueprint name. So the blueprint name is the name of the struct that we have at the top here. And so my blueprint name is token sale. And then it requires a function name, and the function name here is new. And then it takes any arguments that we have. And so one of the arguments that we have here is price per token, which is a decimal. So I'm going to set the price per token at 10. And I'm going to go ahead and call this. Fantastic. So we see that the transaction was indeed successful. And when we do a resim call function, it gives us a lot of logs for many different stuff. And all of this is very useful, but I don't want to get too much into detail into what these logs are at the current moment of time. Just know that when you actually begin your Scrypto journey, these logs are going to be really useful to you. It also tells us that in the process of calling the new function, the new function created a new component and also created a new resource. So the new component that was created is to be expected because the new function is a constructor after all that creates a new component for us. And the new resource is this resource that we just created here. So one of the things I would like to do is I would like to actually test the buy method here. So what I would like to do is to first see the balance that I have in my account, the balance of XRD I have in my account, before calling the buy method, and then call the buy method and see how much XRD I have in my account and how much useful tokens I have in my account, and sort of do the math and see if the math does actually match. So how do I see the balance that I have in my account? There was this command called resim show, and it shows us the state of components. So I'm going to scroll up to get the account component address from up here. Then I'm going to scroll down. I'm going to do a resim show over the account component address. And so this tells us how much resources we have in our account. So what I'm trying to focus on in this is this line down here. The stuff at the top is very useful, but I don't want to get into it at the current moment of time. What I'm focusing at is this line down here that tells us that we have 1 million of a resource with some resource address that has the name of Radix and a symbol of XRD. So fantastic, we have 1 million XRD. So now I would like to call the buy method, and I would like to give the buy method 100 XRD. So if you remember from the call function that we did earlier, we said that the price per token is 10 XRD. And so if I provide my component with 100 XRD at a price of 10, I should get 10 useful tokens back. So that would be 100 divided by 10 gives me 10 useful tokens back. So I'm going to do that. So I'm going to do resim call method. If you are unsure when to use call function and when to use call method, it's very simple. If you look at a function and it does not have a reference to self, then that is a call function. If you look at a function and it has a reference to self or a mutable reference to self, or it takes ownership of self, then that is a call method as it requires component state. So I'm going to do a resim call method, and I would like to also show you the useful stuff that resim provides. If I just do resim call method, resim is going to tell me the arguments that it expects for the call method. So here it tells me that call method requires a component address and a method name. So let me do resim call method. It requires a component address, so that would be the component address of the component that we just created, of the token sale component. And it requires a method name, which would be the buy method. And it takes whatever arguments. And so the arguments that we need to give it, is a bucket of funds. And so the way that you provide a bucket in resim is by specifying the amount and then comma and then the resource address of that. And resim is going to take that and it's going to translate that into a bucket. And so if you're wondering where exactly I got this long resource address from, it's from the resim show command that I did earlier that told me that I have 1 million XRD in here. From here I got the resource address that essentially said you have 1 million XRD, and so this is the resource address that I'm using. So quick recap, I'm doing resim call method with the component address of the token sale component that we just created. I'm calling the buy method, and I'm calling that buy method with 100 XRD. All right, so calling this method was successful, the transaction was successful, and it is giving me some logs as to some of the things that happened in this transaction. Let's not go into detail as to what all of this mean. Let's actually, well, what I want to do now is I tried to buy some tokens. What I want to verify now is that some tokens were taken out of my account, some XRD was taken out of my account, and as a result of this, I obtained some useful tokens back. And so, again, to query the account balances, you do that through resim show, and then you provide the component address. All right. So again, I am focusing on this part down here, the part that I've highlighted. All of this is very useful, and you're gonna need it in your Scrypto journey, but we're not diving into detail at the current moment of time into that. I'm focusing on resources now. And so we see that we have 100 less XRD, which is exactly as expected. We sent 100 XRD to the buy method, so we have 100 XRD less. And at a price of 10, we were given 10 useful tokens back. Fantastic, the math does actually work, and it does actually check out. So that is amazing, that is great. All right, so what we built here is good and it's exciting, but we can improve this. Because there's one thing that we have not done so far, which is, at the current moment of time, the token sale component takes the XRD that was sent to it. And so we want to provide the seller with a way to then call this component and say, hey, you have XRD, give me the XRD. I am the seller, I am the person who created this resource. I would like the XRD obtained from the sale. And so if you're somebody who's programmed in other blockchains in the past, perhaps the first thing that comes to mind is, oh, let me just use the caller address, and what I'm going to do is that I'm going to say that if this person calls you, allow them to be able to call the withdraw funds method, allow them to be able to call whatever authenticated method, and you might think that, let me just do authentication through caller address. But the thing is, this isn't the way that we do it in Scrypto. We have a completely different way of doing it in Scrypto. For starters, we do not have a notion of a caller address in Scrypto, and we do not have this notion for many, many different reasons. The simplest of which and the easiest of which to explain is because if you have a transaction manifest that calls many different things and there are multiple signers signing the same transaction manifest, then who exactly is the caller in this case? Is it this one person? Is it all of these people? And so it's a little bit complex to think about caller address in the context of a transaction manifest, but there are also many, many, many other reasons. If you've programmed in any EVM environment in the past, you know that caller addresses can be easy to manipulate, especially what I'm talking about here is delegate calls and all of these different things that can sort of manipulate the address of the caller to make them appear as a different person. And so the caller address can sort of be manipulated in some certain cases. Also, this assumes a one-to-one mapping of public keys to accounts. To explain this a little bit better, in Radix, you can have a private public key pair that controls multiple different accounts. And so a private public key pair doesn't have to just control a single account. It can control many, 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 many different accounts. And yeah, it essentially controls all of them. And the idea of a caller address doesn't work very well with this model. In addition to that, if you've programmed in Ethereum in the past, you know that if you have some kind of complex organization that you want to model in terms of auth in any EVM environment, this can be really, really complicated. So I want to give an example here of some kind of organization that wants to secure some method that allows the withdrawal of funds. And so let's say that we have this method and we want to secure it so that only a supervisor and admin and super admin have to approve the withdrawal of funds, or a founder and 8 shareholders. Representing this kind of thing with the caller address is quite complicated and really unintuitive. And in addition to that, there is many different methods and functions that you need to implement in case you need to do auth handoff. And if you forget to do these, if you forget to implement these functions, then if you ever decide to sell your dApp, you're also going to have to sell your public and private key pair. And so with Scrypto, we decided to do authorization through a completely different form. And so authorization in Scrypto is done through what you have instead of who you are. Or to rephrase this a little bit, it's done through what you have and not your account address. And this idea of doing authorization through this format has many, many different advantages. Before I talk about the advantages, let me give you a quick rundown of the system that we have. The system that we have is a system of badges. Badges are just normal resources, and you can provide a badge essentially to say that this person has been given authorization to do something. You provide them with a, let's say, special resource of sorts. And so when this person needs to do some kind of privileged access thing, they go to the component and they show their badge. They do not give their badge to the component. They only show the component their badge. Hey, look, I have this badge. I own this badge. Allow me to do this thing. And so this is the system that we have, which translates into what you have and not who you are. The advantage that this has is that it makes role-based authorization incredibly simple to model. And if you do not know what role-based authorization is, it's this idea. Let's say that you have some company and you have people in the finance department which you want to give access to some parts of your system to people in the finance department. You have the operations department and you want to give access to some parts of your systems to the operations department. And let's say that you have some kind of developer team and you want to give access to certain parts of your system to the developer team, but also you have privileged people that can have access to operations and finance at the same time. And you also have some privileged people that can have access to, let's say, finance and developer systems at the same time. And so this idea of role-based authorization is incredibly simple to model through the system of badges that we have. And we're going to see a bit of an example of this in code to guarantee to you that this is actually really simple to model. In addition to that, you do not need additional methods to do authorization handoff. So let's say that you've created a dApp, the dApp has been incredibly successful, and you're like, all right, I am done with this dApp, I wish to sell it, I would like to give it to this large company. What you do is that you say, all right, you want to have this thing. When we sign the contract, I'm going to send you the badge that I was using to give me privileged access into this component, and that's it. The auth handoff has been completed. And in addition to that, and this ties into the first point, modeling complex auth with badges is really simple because badges and the notion of badges is integrated very well with Scrypto, and so modeling all of these things is really easy to do in Scrypto. So enough of me talking theory, let's take a look at an actual example. And let me go back to one of my favorite examples, which is this example, just because it truly highlights the power that Scrypto gives you. Again, let's say that we have some kind of system, and more specifically, let's say that we have some kind of withdraw function, and we would like to say that this withdraw function can only be called if a supervisor admin and super admin authorize this transaction, or a founder and 8 shareholders authorize this transaction. How do we model this in Scrypto? After we create the badge resources, here is how we set this access rule. We essentially say we would like to require that the supervisor badge and an admin badge and the super admin badge are present, or we would like to require that a founder and 8 shareholder badges are present for this operation to take place, and then we can take this access rule and plug it into something. But this is how you model this complex organization in a very simple access rule. It is incredibly simple to do, and there are many amazing things that you can do with access rules, and I can talk about this one thing for hours. So I talked about authorization because I wanted to lead you to this point. We would like to offer methods for the seller, for the original seller of tokens, to be able to do some privileged operations on the component. More specifically, we want the original seller to be the only person who can withdraw funds from the component, and we want the original seller to be the only person who can change the price of tokens. It doesn't make any sense if you allow anybody to change the price of tokens. That wouldn't exactly be a very good token sale in my opinion, but yeah. So we want to reserve these two methods to sort of be privileged methods that can only be called by the original seller of tokens. So let's go ahead, implement this in code, and see what this is going to look like in Scrypto. So let me do this. So the first thing I want to begin doing is I want to begin by implementing these methods. And these are going to be really, really simple methods. There isn't going to be anything special about them. Withdraw funds, takes a mutable reference to self, takes an amount that the person wishes to withdraw, and returns a bucket of tokens. Again, extremely simple method. All that it does is self XRD tokens vault, take amount. So quick recap over this method. This is a withdraw funds method. This method takes an amount, and this amount is a decimal. This amount essentially defines how much tokens we are going to be withdrawing from the component, or how much tokens we're going to be withdrawing from the vault. The vault that we're going to be withdrawing funds from is the XRD tokens vault, and we're essentially saying self.xrd tokens vault, and we would like to take some amount from this vault. And so this is quite a simple method. Let me also define a method to change the price. I'm going to call this change price. And this will be a mutable reference to self. And this takes the new price that we would like to set for the tokens. So this will be a decimal argument. And we're not going to be returning anything. We're only going to be modifying the state, changing the price. There isn't going to be anything that we return in this case. And so let me do this. Self.price per token is equal to price. So let me do a quick rundown of all of these things. Maybe I was going a bit too quickly. Let me do a quick rundown of what all of these things are doing. Stop that. So we implemented two additional methods on our blueprint. One is called withdraw funds, and we would ideally like the withdraw funds to only be callable by the original seller of the tokens. We take the amount of tokens that the seller wishes to withdraw out of the component, and we return a bucket of tokens. To withdraw some funds from this component, we call the XRD tokens vault, and we call a special method on the vault called take, and we take the amount that the seller wishes to take from the component. We also implemented a change price method, and the change price method takes a price which is a decimal, and then it sets that price as the new price of tokens that they will be sold at in the future. But there's a bit of a problem here, namely that these methods can now just be called by anybody. And obviously we don't want that to happen. We do not want everybody to be able to call the change price method. That wouldn't be a very good token sale. So we want to restrict this so that only the seller can call these methods and nobody else can. So what we want to do here is we would like to create a badge that we provide to the seller, and then say that only this badge or only a holder of this badge can call these authenticated methods. So let me go ahead and create the badge. As I said, badges are normal resources. There's nothing too special about them. So this is a seller badge, and it will be put in a bucket. Let me type all of this down, and then I'm going to explain what exactly all of this does, but it will pretty much be the same as what we did previously. So again, I'm creating a very bare-boned resource, nothing too special about it. I'm calling the new fungible method on the resource builder to create a new fungible resource, and I'm saying that this resource is only going to have a supply of 1. So let's actually go ahead and introduce some useful identity to this badge. We haven't given it a name, we haven't given it anything. Let's introduce some identity to this badge. I'm going to provide a name, which I'm just going to call seller badge. And I'm going to provide a symbol of seller. Also, I would like this badge to be indivisible. And so the idea of something being indivisible essentially means that you can only have 0 badges, 1 badge, 2 badges, but you can never have 2.5 badges. You can never have 2.3 badges. And so I would like to make this badge indivisible. There can either be 0 or 1 or any multiples of 1, essentially. So I do that through the divisibility method, and I will specify divisibility none on this resource. So now that we've created the seller badge, we need to give it back to the person instantiating this component. And so what we do here is that instead of returning a single component address, we're going to need to return a component address as well as a bucket, and this will be our return type. The component address will be the address of the component that we just created. The bucket is going to contain the seller badge that we wish to provide to the seller when they instantiate a new component. And Rust is going to scream at me now. It's going to tell me you're doing something wrong, so let me actually go ahead and fix that. So what I did here is that I essentially said that this statement down here, which creates the component, I got the component address into a variable, and what I wish to do now is to return the component address as well as the seller badge back to the caller. So what we've done now is that all that we've done is that we've created the seller badge and we've defined these methods down here. But we haven't exactly linked the seller badge to the methods down here. At the current moment of time, we just have a seller badge, but it doesn't exactly do much. So let's actually go ahead and define what are the methods that the seller badge can call that nobody else can call. And we do that through an access rules object. Access rules. Let me type this down first. All right. So default, or let me not define a default now. All right. So to define who can call a method or the badges required to call a method, we do that through an access rules object. And the way that you do that is by doing access rules new, and then you call a method called method, and the method takes 2 arguments. One of them is the name of the function, so withdraw funds. And once I type this down, it's all going to make sense. So let me actually go ahead and do that. Rule require seller badge resource address. So let me actually clarify what all of this is doing so that you're a bit clear about what all of this does. We're actually trying to connect the seller badge to the component to say that this seller badge is the only thing that can call these methods. And so what I'm doing here is that I created a new access rules object, and I said that the method withdraw funds can only be called that it requires a seller badge. It requires that the caller does indeed have a seller badge that they can present. And when they do, then this method can be called. We're essentially going to be doing the exact same thing on the change price method. It's going to be identical. Again, withdraw funds and change price methods are only callable when a seller badge is present. Other than that, they cannot be called. And I'm going to set a default, and I'm going to tell you in a little bit what the default thing does, but you can probably guess by the name. Allow all. So what we have here is this 2 access rules for the withdraw funds and the change price, and we also defined a default of allow all. The default essentially says that any methods that we have not enumerated here or that we have not provided access rules for here can be called by anybody. So the only method that we have not defined any access rules for is the buy method. So we're essentially saying that the buy method can essentially be called by anybody, and there is no restriction on who exactly can call the buy method. Anybody can call it. So we've created this access rules, but we haven't exactly used it anywhere. So let's actually go ahead and make use of these access rules. So in between of instantiate and globalize, I'm going to call a add access check, and I'm going to provide it with the access rules that we have defined at the top here. So This might have been a bit complicated. Let me walk you through what we have done in this demo so that you're a bit clear about what we did. I began by defining two additional methods, which I am hoping that only the seller is going to be able to call. One is called withdraw funds, and the other is called change price. Withdraw funds takes an amount of tokens and it returns a bucket containing this amount of tokens. And the way that it does that is that it takes this from the vault. The change price allows the seller to change the price of the tokens on the fly. Maybe they were like 10 XRD is way too high. People are not buying my tokens. Let me change that to 5 XRD. Or maybe they're like, my token is incredibly successful. Let me increase the price to be 100 XRD. And so they can change the price. But the problem that we had once we wrote this is that we were like, well, anybody can call them. We want to secure them in some kind of way. So what we did is that we came up here. We defined a seller badge, which we provide to the seller once they instantiate this component. And then we defined some methods, or we defined the access rules that apply to some of the methods and how exactly they relate to the seller badge that we created. And then at the end, we returned the component address as well as the seller badge that we have just created. So, cool. Let's actually go ahead and test this and see if it functions the way that we expect that it does. As always, I will go ahead and begin with a resem reset. To recap, resem reset resets the state of the Radix engine simulator, and it essentially, if it found that we had already deployed a package in the past, it removes this package, it removes whatever accounts that we've created, and it essentially allows us to begin completely anew. So let me do resem reset. And in this case right here, what I would like to do is that I would like to create two accounts. One account is going to be used by the seller and the other is going to be used by the buyer. So I'm going to do a resem new account, and I'm going to do this twice. Again, if you remember, an account is not special, an account is just a normal component. So an account has a component address, and this is the component address of the seller account, and this is the component address of the buyer account. So what I would like to do now is that I would like to take the code that we have and publish it to the Radix engine simulator. So I do that through resem, publish, and then dot. And what this does for me is that it essentially publishes the code that I have in the current working directory. And it gives me a package address. All right, so what I'm going to do now is that I'm going to call the new function on the token sale blueprint to create a new token sale component. And again, if you've just joined the stream or if you've just joined the event, resem is going to be able to provide you with a lot of help if you just do resem call function, or if you just do resem whatever subcommand that you need and then provide no arguments. Resem is going to be able to tell you these are the arguments I expect for each of the subcommands. So again, to demonstrate this, if I call resem call function without any arguments, it tells me, hey, I expect a package address, a blueprint name, and a function name. And so these are the things that you're going to need to provide whenever you do resem call function. So let me actually do it correctly this time. Resem call function. It has said that it requires a package address, so I can get this from here when we publish the package. It says that it needs some kind of blueprint name, which is the name of the struct here. And then it says that it needs a function name, which is new. And it takes whatever other arguments that the new function requires, and the new function requires a single argument of price per token. Again, for simplicity, I like setting the price per token at 10, just because it makes it very easy to do math, and 100 divided by 10 is equal 10, really easy. Fantastic. So calling this function was successful. The transaction was indeed successful. And in the process of calling the new function, we have created a new component and two new resources. And so the way that these are ordered is according to which one was created first. So this resource address here belongs to the useful tokens, and the resource address down here belongs to the seller badge because the useful tokens were created first, The useful badge was the seller badge was created second, and so these things are actually ordered, and they tell you they are ordered in the order of which one was created first. And we also have the component address here of the component that we just created. All right, so now that we have this, let me outline to you the test that I have in mind that I would like to run to make sure that this demo is actually working in the way that I expect it to work. I would like to buy some tokens using the buyer account, and then through the seller account, I would like to ensure that I can withdraw these funds out of the component. And if we're able to do that, then fantastic, this thing works exactly as I expect it to work, and the demo is completed. So if you remember, we created two accounts. The first one over here was for the seller, and the second one down here is for the buyer. So let me change the default account in resim, which is using a command called resim set default account. Again, to demonstrate, resim is able to help you and tell you the arguments that it expects and the argument that it needs. Just type in a subcommand, leave it empty, press enter, and it tells you these are the things that I expect. So in this case, it says to set the default account, I am expecting a component address as well as a private key. And once you give me those, I'm going to be able to set the default account for you. So let me get the component address from the top. And then let me also get the private key from the top. And the default account has been updated. So let me get the balances of my buyer account to see how much XRD it has. And based on that, we can make sure that the math is actually happening correctly. When I buy tokens at a certain price, I am indeed getting the amount of tokens that I should get. The amount of tokens that should be taken away from me are indeed being taken away from me. So if you recall, we do that through a resim show command, and the resim show command takes a component address, and the component address is going to be that of the buyer. And so again, what I'm focusing on is the part down here. The part that says that I have a million XRD, I have a million of a token with some kind of resource address, and this token has a name of XRD and a symbol of XRD. So let me actually go ahead now and call the buy method on this component. I'm going to do resim call method. Again, let's do the tradition of letting resim tell us the kind of arguments that it is expecting. Call method takes a component address and takes a method name, and optionally takes any optional additional arguments that might be needed. So we would like to call the buy method on the token sale component. If we scroll up, this is the component that we have right here. And we need to provide a method name, which is the buy method, and we need to provide it with some arguments. If we check the buy method over here, we see that the buy method takes a single argument of funds, which is a bucket. As I told you, the way that we construct a bucket in resim is by saying the amount, comma, the resource address. So 100 XRD can be represented as 100, comma, and then the resource address of XRD, which we can get from up here, from querying the amount of funds that we have. All right, so we were able to buy some tokens, and as you can see here, it's saying that the transaction was successful. So we were able to buy some tokens. So let's now make sure that the math is actually happening correctly. At a price of 10, and when we send 100 XRD, we should get 10 tokens back. We should have 100 XRD taken away from us, and we should get 10 tokens back. So let me check the balances of my account component to make sure that this is indeed true. So right here, I have 100 less XRD, and I have 10 useful tokens, so that did indeed work. That is really, really good. But what I want to show you is something else. Like all of this, I've shown you all of this in the previous demo. What I want to show you now is a transaction failing. And the transaction that I want to fail is the buyer trying to withdraw funds from the component, trying to go to the component and say, hey, I am the seller, give me your funds, I want them. So let's actually construct that. So I'm going to do resim call method. And what I'm going to need, actually, let me go up. So I'm going to use the same command from previously, resim call method on the token sale component. And what I would like to do is to say withdraw funds, and I would like, let's say, to withdraw 100 XRD as an example. And again, theoretically, this should fail. I am the buyer, and I'm trying to withdraw funds from the token sale. I'm trying to withdraw the funds belonging to the seller. This transaction should theoretically fail, and if it succeeds, then something bad is happening. Ooh, there we go. And it fails. It tells us there's an authorization error. And it says that the withdraw funds method has some kind of authorization, and because it has some kind of authorization which I did not fulfill, it has some kind of auth rules which I did not fulfill, and because of that, I will not be able to call this method. That is really good. Let's now switch to the seller account and make sure that we're actually able to call this method. So that can be done through resim set default account. Again, I would like to do this just to show you how friendly resim is. Resim is going to tell you the exact arguments it needs. So to set the default account, it needs a component address and a private key. I have these at the very top over here. And these two, component address and private key, belong to the seller. All right, fantastic. So we have switched to the seller's account. Now we're acting as the seller. So to call the withdraw funds, I actually want to demonstrate the withdraw funds through the transaction manifest. So far, the way that we've been calling all of this has been through resim, and when we have been letting resim do all of this stuff for us. But I told you about the transaction manifest, and I told you about what it can do. And I would actually like to use it here to show you the power of what it can bring. So I'm going to come here and I'm going to create a new file. I'm going to call it tx.rtm. So tx is transaction.rtm is Radix transaction manifest. And if you remember, the stuff that we've been doing with resim has mostly been call function, call method, call function, call method. This is exactly what we're going to do with the transaction manifest. Call function and call method. This is pretty much it. So what I would like to begin doing is to get the seller badge from my account. I am the seller. I would like to get the seller badge from my account. And I can do that by doing a call method on my account. So it's requesting me to provide a component address of my account. I need to provide a method name. And the method name, it's a special method called create proof. And it takes a resource address, and that resource address is going to be, let me just make this multiple lines so that it is easier to read. The resource address here is going to be of the seller badge resource. So if I scroll up, it should be it should be here. Let me just check something, which one was created first. The useful tokens was created first. Seller badge was created second. So this is the resource address corresponding to the seller badge. And so let me put that here. So what I'm essentially saying here is that I am saying call the seller badge, call the seller account component, call a specific method called create proof, and the proof that we would like to create is of this resource address. The idea of a proof is that if you want to show a component that you are in possession of something without giving it to the component, you create a proof. And so a component takes a proof, but it doesn't actually take the resource away from you. It doesn't take the badge from you. It takes a proof of ownership of that badge. So now that I have this, what I would like to do is to call the, let's see, the withdraw funds method on the component, on the token sale component. This is going to be very useful. Again, it's going to be another call method, so I prefer to just copy it. So the component address is going to be that of the token sale component. And the method that we're going to be calling is the withdraw funds method. And the withdraw funds method takes one argument, which is the amount, and the amount is a decimal. So I'm going to provide a decimal of 100. So what I'm essentially saying here is I would like to call the token sale and I would like to withdraw 100 XRD. This is essentially what this line is saying. Once I have the 100 XRD, it is available in the transaction worktop. So I need to define exactly where is this 100 XRD going to go. And so what I'm going to define here is that I'm going to say, take this 100 XRD and put it in my account as the seller. So that is done through a call method with all resources, which takes a component address. Right. Call method with all resources takes a component address and takes a method name. The component address here is that of the seller account, and it takes a single method name, and the method name here is deposit batch, which is the method that we wish to call to take all of the funds from the transaction worktop and put them in our account. So this is a very quick example of a transaction manifest. And just to highlight, if you would like to take a closer look at this, I can answer whatever questions that you would like, or I can send this to you over in Discord and we can have a chat about it if this is not too clear to you. So yeah, keep this in mind. So we have written this transaction manifest. Let's actually go ahead and run this. So I'm going to do resim run in true resim fashion. Let's see what it takes. Resim run takes a path. I'm going to provide it with tx.rtm, and woohoo, that was successful. So to recap here, we were able to have methods on this component that have some kind of authorization. The withdraw funds method, when called by the buyer, was unsuccessful, but when called by the seller, the function call was successful. And this is one of the powerful concepts about Scrypto. It's this idea of authorization through badges. And so this concludes the demos that I wanted to do. So I'm gonna open this up for questions. If you have any questions, or if there is anything on your mind, scan this QR code. It takes you to Slido, and I'm gonna be answering any questions that you have right now live. So go ahead and scan this QR code. Right, so we have the first question here, which is, what is the difference between Ethereum's ownable and the Scrypto way of doing authorization? If you're somebody who comes from the Ethereum world, the ownable contract is a very, very famous contract developed by a team called Open Zeppelin. The ownable contract is a contract that you typically inherit. So you say that, as an example, my ERC token is ownable. My ERC token can be owned. And when you say that a token is ownable, when you say that a contract is ownable, it essentially says that there is some account address that owns this contract who can access some privileged methods on this contract. And so the ownable thing is Ethereum's way of doing authorization, and one of the shortcomings of the ownable contract is that it only allows for one single person to be the admin or to be the owner of a contract. The Scrypto way is completely different. You're not going to be inheriting any contract. You're not going to be doing any of that. The first big difference here is that ownable requires the caller's address. The Scrypto way of doing things uses badges. And as I have demonstrated and talked to you about, badges is the Radix way of doing things, and it is the asset-oriented way of doing things. And so this is the main difference between Ethereum's ownable and the Scrypto way of doing authorization. What is the name of the RDX VS Code highlighter extension? Thank you. Yeah, this is an extension that I've built myself and I'm using it. It's a very quick extension just to get me some syntax highlighting. It's not available on the VS Code marketplace yet, but I can share with you the files or the GitHub for that if you would like to give that a try and to use it. And yeah. How is the Radix chain secured? So what I'm assuming that you're asking here is like the kind of the consensus algorithm that we have. So the Radix chain is proof of stake and not proof of work, and the proof of stake is done through the native token that we have on the Radix ledger called Radix. And so Radix is a proof of stake network. So what does deposit batch do exactly? What is the purpose of it in the RTM file? This is a really, really good question. So let's go back to the code here and let me kind of extend this a little bit. The deposit batch essentially says that you might have many different tokens in your transaction worktop. So maybe you have withdrawn funds from this component, and maybe you've withdrawn funds from another component and another component. Maybe you're doing 10 token sales on 10 different components, and you want to have this one transaction that withdraws all of the funds that you are owed as a seller, and then takes these funds and deposits them into your account. And so deposit batch essentially says, I will take a vector of buckets, and I will put this vector of buckets in the account. So let me go back to the questions. Why is a badge fungible instead of non-fungible? I think that this is probably one of my favorite questions, and this is the beauty of Radix. A badge does not have to be fungible, and matter of fact, the usefulness of badges comes when they are non-fungible, and this is when you begin having a badge that defines the name of somebody, that defines, as an example, let's say that you have a lending protocol. The badge can define how much funds this person has withdrawn or how much funds has this person been lent and all of this kind of stuff. And so a badge does not just have to be fungible, it can be either fungible or non-fungible. Did I lose that question? I put the question somewhere, but I kind of lost it. I was answering the question about why does a badge need to be fungible? It does not need to be fungible. It can be fungible or non-fungible. And there is a massive, massive, massive use case for non-fungible badges that is incredibly, incredibly powerful. So what blockchain does Scrypto run on? It runs on the Radix ledger, and we have a lot of information about the Radix ledger. And so if you're attending in person, some of the people organizing this event can provide you more information about Radix and about how it works. And yeah, it is running on the Radix ledger. How do deployed components run on the whole network? I'm not exactly sure what you mean by that question. How do deployed components run on the whole network? If you're still available, just clarify a little bit more on what you mean by this question. I'd be more than happy to answer this question for you. So just, yeah. How is the security guaranteed? Well, there are many, many, many different ways that we guarantee security. One of the very first things that we use to guarantee security is that tokens can never be lost. And so we have this idea of buckets and vaults. And so a bucket can never be left unattended to. A bucket at the end of a transaction must be put in some kind of vault. And so you will never have this kind of bucket that is unattended to where you lose your tokens. This is number one. Number two, we have completely disabled re-entrancy on Radix and in Scrypto. So this idea of re-entrancy attacks that you see all of the time in Solidity is no longer possible. There is literally no re-entrancy. You cannot re-enter. And we were able to disable re-entrancy because of the way that we do things in Scrypto. We do not need to have re-entrancy. However, we are keeping an open mind. If somebody gives us a really good use case of re-entrancy and says this is a really, really good use case for this and like we absolutely need to have it, this is something that we are keeping an open mind to, and we're open to changing in the future if somebody presents a good use case for it. In addition to that, there is an additional thing that I wanted to mention about guaranteeing security, which is that tokens are actually native to the ledger itself. One of the problems that you very quickly run into when you're developing in Solidity is that you have these tokens or ERC20 tokens with no guaranteed behavior. They run in some kind of way, but you really don't know how they run. And so this is, as an example, you have a transfer function, but there is no guarantee whatsoever that a transfer function actually does transfers. Maybe a transfer function is completely disabled, and maybe the transfer function does minting. Maybe the transfer function actually burns tokens and takes them away from you. And so you've got these tokens that function more like black boxes than anything. And on Radix, we decided to take a completely different approach. We said we want tokens and we want resources to be a native part of the blockchain itself. And so one of the things that you're going to see is that we never say the Radix native tokens. All tokens are native. There is one token that you use to pay fees and to do staking with, but all tokens are native. So there are multiple layers to this, and Radix guarantees security over multiple different layers, and yeah. What is the story for contract code upgrades? Really good question as well. This is one of the things that we wish to support natively. Might not be something that we can do at Babylon, but this is one of the things that we wish to do natively at some point of time, some kind of upgrade feature that you can do. And so at some point of time, this will be available natively, might not be at Babylon. What about Ripple's XRP and how is it different from Cardano? I do not know too much about Ripple. I know a little bit about Cardano, and maybe I can speak a little bit more about the Cardano side of things. I guess one of the biggest advantages that we have over Cardano is that the language that we have is more high level, and so you're never going to be finding yourself dealing with individual UTXOs or needing to specify individual UTXOs when you're doing all of your transactions. And this is one of the biggest advantages that we have over Cardano. We have an abstraction layer that means that you essentially, as a developer, never need to know about the existence of UTXOs, which we call substates in Radix. You never need to know about their existence. The language is high level enough to abstract all of that away from you and essentially make you never need to deal with any of that. So I would say that Radix and Scrypto is more of a high-level framework, and there's also a lot of differences when it comes to the consensus algorithm and sharding and all of that. And so, yeah. So are there transaction fees involved? Really good question. As of Scrypto 0.4, there are no transaction fees. Transaction fees will be added in Scrypto 0.5 or a release in the future. But at the current moment of time, transaction fees are not implemented. Just to highlight, Scrypto is currently in preview, and so Scrypto at the current moment of time is not running on a live ledger. It's only running in preview, and so in the preview version of Scrypto 0.4, we do not have fees. We are hoping to have it in 0.5, but I do not want to make a promise which I might not be able to keep, but this is the current plan. Can badges be made non-transferable? Really, really good question. Amazing question. I guess this person might have read the Soulbound article, the article about Soulbound tokens. Yes, badges can be made non-transferable. Matter of fact, you know what? Let's very quickly make a badge that is non-transferable since we have time. Let's go to the seller badge, say that it has restricted withdraw. The rule here is deny all. Nobody can withdraw this resource, and it is locked. It is forever not withdrawable. So, really simple. Now the badge can no longer be transferred. I am keeping restricted deposit as off because we're going to need to deposit this badge somehow. So I'm just applying restricted withdrawal. Really, really good question. So if the person asking this has knowledge of soulbound tokens, they are incredibly simple to implement in Scrypto, like really simple. And there is a fantastic blog post written by Matthew Hein, our Chief Product Officer at RDX Works, that talks about soulbound tokens. Really beautiful article. I would recommend that you give it a read. And yeah. All right, so I think that this is all the questions that we have. There are a lot more questions. I would like to get into all of these questions in details. Everybody here submitted really, really amazing questions, but unfortunately, because of time constraints, I cannot go into detail into all of the questions. So I'm gonna move over to the final part of this presentation, which is a challenge. So we have a challenge which we would like you to do for the remaining portion of the day. You see all of the stuff that I implemented today, we would like you to implement the same thing. And do not worry, this is a guided challenge. There's gonna be a long document describing to you everything in great detail. You're just gonna need to implement things. And this is not a test. This is not some kind of difficult thing. If you ever need help, we are available in Discord. I am personally available in Discord, and I'll answer whatever questions that you have. I'll talk to you. I'll discuss things with you. And other people from the community and from the team are going to be in the Discord. So do not take this as a test. It is the furthest it can be from a test. This is a fun challenge just to get you to try Scrypto out, just to get you to have a feel for Scrypto, and to give this a try. So high-level overview, what would we like you to implement? We would like you to implement the same token sale blueprint that I described to you today. It has two vaults, one vault that is going to store the tokens that you create, another vault is going to store XRD tokens. It has some data, which is the price, and it has multiple different methods, which is the buy, withdraw funds, change price, which allow you to do all of the things that we have already described. And it has a function called new, which is a constructor. So a little bit more detail. I kind of hinted, I told you there is this really long document describing everything in great detail. Where do I find this document? If you are an online attendee, you should be able to find this in the YouTube description. If you do not find it immediately, refresh and you'll be able to find it, and you'll get to this document. If you're somebody attending in person, then at this moment of time, you should have probably received it. You should have probably received it to your email. If you haven't, you can get some of your teammates to help you out. You can get some of the people that are attending in person to help you out. Or if nothing else works, I'm available in Discord. I'll help you out. I'll send you the document. So a little bit more detail about the challenge. The submission deadline is today, which is Saturday, 23rd of August, 2022 at 18 CET. And for all of this, you're going to need to have an Eventbrite ticket number. And so this is one of the things that you're going to need. For people attending online, this is an individual challenge. And if you complete this challenge successfully, you will be given $10 in XRD. This is if you attend online. And the $10 in XRD will be given to the first 100 people who submit a blueprint that fits the judging criteria that we have. For people attending in person, however, we have a more fun thing that we would like to try out. So we have larger prizes for people attending in person, and what we have is that the prizes increase as you have more and more people in your team. So you can have teams up to 4 members, and if you have a single member in your team, you get $25 per member. If you have 2 members in your team, you get $30 per member. If you have 3 members in your team, you get $35 per member. If you have 4 members in your team, you get $40 per member. And so again, this is the details of the challenge, exactly the same token sale as the stuff that we've talked about. The document is going to be available to you if you're an online attendee. YouTube description, you can refresh if it's not immediately available. In-person attendee, it's going to be sent to your email, and that's about it. So moving forward, I cannot emphasize this enough. Join our Discord. People in the community are going to be so welcoming, and I think you're going to have a great time in our Discord. I'm going to be available all day long today. If you need any help or if there's anything that you need, I'll be available to help you out to ensure that you successfully complete this challenge. Again, the challenge is not a test. It's not some kind of really big challenging thing. It's a really simple thing, and would like you to be able to complete it. So I'll be available to help you out. So join our Discord, and I'll be personally available there to help you. There is a specific channel that I recommend that you join. It's called Scrypto Rust Beginners. I'll be personally available there, but you can chat in any of the channels. I'm not going to control you. If you found this event to be useful, and if you found it to be interesting, we're planning many different events in the future, and we're planning on going with Scrypto to many different other locations. If you would like to stay up to date with the things that we have planned, join our developer program, and we'll be sending you an email twice a week informing you of the things that we're up to and informing you of all of our updates. And this is the link that you can use to join our developer program. This has been Omar, developer at RDXWorks. I've introduced you to Scrypto. I hope that you had a fun time with Scrypto, and I'll see you in Discord. Everybody, just checking in. Just wanted to say it is absolutely fantastic to get to see all of you in many different locations all around the world getting to work on Scrypto and getting to experiment and build your first blueprint. I've been seeing the pictures, I've been seeing the stream, I've been watching all of these different things. It is absolutely fantastic to get to see all of you enjoying Scrypto and working on that. If you ever have any questions, if anything is kind of not really easy, if something is not very clear, I am in the Discord, I am available, and I'm going to be available all day, so make sure that you jump in the Discord. We're going to be running challenges probably twice a month or once a month, so make sure that you're joining the developer program and make sure that you're staying up to date with Scrypto. Again, fantastic to see all of you working on Scrypto, fantastic to see all of you enjoying it, and if you have any questions, I'll be in the Discord. Goodbye.
Get a minute of your time. Get a minute of your. I sure gotta live right, and I'm never gonna let you out of my side. I've been knocked out, was a nice try, but I guess I get to keep my head on this time. Part of the creation, the relations I've got, the only one that keeps me safe, the only one you should trust. For sure, it ain't right that I have checked the speck of dust from all of its side. Fall down, that from my height, cause I didn't see the plank I have in my eye. In yourself when no one's to be found. What keeps you inside? What takes you off your mind?
Guess you want this, I want this. Everybody in this, we should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them. Take the time to recognize it. You won't leave me even if I tried it. You're the artist, and the mass, and happily be found than you in your hands.
time. Part of the creation, the relations I got. The only one that keeps me safe, the only one you should trust. Yeah, you better. For sure, it ain't right that I have checked the speck of dust from all of its sides. Hold down, that from my height, cause I didn't see the plank I have in my eye. In yourself when no one's to be found. What keeps you eased out? What takes you off your mind? Yeah, you better.
Cause you want this, I want this. Everybody in this, we should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them.
Yeah, you better.
Take the time to recognize it. You won't leave me even if I tried it. You're the artist from the mass and happily perform the new in your hands.
Yeah, you better. Yeah, you better.
Cause you want this, I want this. Everybody in this, what should have it. Stop illusions, it's in your hands. Show yourself, reveal it to them.
Yeah, you better.
Take the time to recognize it. You won't leave me even if I tried it. You're the artist from the mass and happily perform the new in your hands. Bye.